whether you're wearing your senior data scientist hat or your open bracket data engineer closed bracket hat, um, what are the kinds of tools and techniques that you use day to day to make the magic happen?
um, what's funny is that when I learned data science, so much emphasis was like on ML, R, and Python, choose your poison. But essentially, SQL is where it's at. SQL I
Mm.
use all the time. Um, I don't know if it's SQL, SQL. I call it SQL, but
Either.
yeah, I feel like it can be a hot topic debate right there if I wanted to. I have a little flame war on LinkedIn. But essentially, I use SQL so much in my job. And this actually came from my first data science role when I was at Verona Health. So before Humu, what I found was we were working with massive data sets, billions of records. We're using Spark for it, right? And so I'm excited. I'm a new data scientist. I want to use Spark. I want to use Python. And I'm doing my analyses, and it's taking me twice as long to do all my work compared to my colleagues. I'm like, what's up? What's happening?
Ah,
I feel like I'm writing pretty solid code. Well, while I was waiting for my Spark and EC2 instance to try to chug along, they were all using SQL and Athena and working 2 times as fast because their code just they spit out the answers right away instead of waiting for their code. And
all
that was
right.
the moment I was like, I need to learn SQL. I need to get good at this because if I can do as much work as possible in SQL and just preparing my data and getting my data out there, um, and then going into an environment, whether it be Python or R or whatever it may be,
Mhm.
um, it's going to be really powerful. And so going back to Humu, we use BigQuery. We're a GCP company. Um, and I absolutely love BigQuery. I think it's one of the coolest tools ever.
Yeah,
Um,
we use it
they,
too. I love it.
yeah, it's so powerful what you can do with it. And here's the thing is that they literally have thousands of people and billions of dollars being pumped into this to make it run well. Whatever they created will outperform whatever script I create in 30 minutes. And so that's why I go to SQL a lot and these managed services for that.
Yeah.
So I use SQL a lot for
So
analyses.
just to quickly dig into a couple of ideas
Yeah.
there before you move on to the next one is that so with Google BigQuery, in case this wasn't obvious to listeners, it is a SQL-like language. So the syntax is very similar. If you already know SQL, doing Google BigQueries will be very easy for you.
Hmm.
But the managed service that they provide allows you to use those SQL-like queries on massive, massive databases really efficiently. And yeah, so we use Google BigQuery as well, and I love it. We're also a GCP company, so that's going to be my bias.
Yeah.
Just so people know, that is the cloud provider that I use the most, and that we made the decision to use a while ago. So I support that. You also mentioned when you were talking about in your previous company, when you were talking about your colleagues using SQL, you talked about them using something called Athena. That isn't something I've heard of before. So that's something that allows SQL queries to be scaled up to very large data sets.
So it's been a while, and please double check, listener. But to my understanding, Athena allows you. So there's Athena and there's Redshift. These are
Mm.
AWS kind of services.
Right,
Redshift's a typical
right.
data warehouse. To my understanding, Athena allows you to query directly on top of your data lake. Um, and so to reference that rather than going directly into the data warehouse. That is my understanding from 3 years ago.
Cool. All right. That sounds great. All right. So I interrupted you. You were talking about data retrieval, and then you were going to move on to analysis, I think.
So essentially, is we get this data ready in SQL. We create all these kind of data assets, what using SQL. From there, I bring it into either R. So we use R for a lot of our analytics. Honestly, I think R is probably one of the best for statistics and the type of analyses we're doing a lot of observational studies,
Hmm.
especially like multi-level modeling.
Hmm.
R is gonna
Oh, yeah.
be a
R is the
beast
best for
for that.
multi-level modeling. Yeah, yeah,
Yeah.
yeah.
And if you think about the reason why we're doing multi-level modeling is like you're working about workforces, you have different departments, different teams, or different locations. Multi-level modeling really handles that very well.
Yeah, it's a technique that we have talked about recently on the show. So we talked about it in last week's guest episode, in episode 585, Thomas Wiki. We also talked about, in that episode, we were talking about using Bayesian statistics with the PyMC library
Mhm.
to have hierarchical models. But if you're not doing Bayesian statistics, then certainly R is, and maybe even if you are doing Bayesian statistics, which is relatively rare, um, R is the place to do it. And that is how I really got into R in the first place, because prior to R, I was using MATLAB mostly for my analyses.
Mm.
And it was Andrew Gelman and Jennifer Hill's book called something like Multilevel / Hierarchical Regression Models in R.
Yeah, there's a whole
And
bunch of names for it.
yeah, but so yeah, you know that book. It's like the Bible in this space, the R hierarchical modeling space. And
Yeah.
I'm super excited at the time of recording. So by the time that you get to listen to this, listener, I will have had the opportunity to meet both Andrew Gelman and Jennifer Hill in person at a conference, the New York
That's
Art
awesome.
Conference, which at the time of recording is in the future, but at the time of listening is in the past.
Amazing. And also for the listeners of like, if you're like multi-level modeling, what is that? Why would I use that? I
Oh yeah.
think multi-level models, one, they're still confusing to me because they're one of those things where you have to keep on trying over and over again. It's not like riding a bike. I feel like I forget it if I don't use it after a while. So I have to like review the literature because I'm in data engineering world now. I'm not doing the analytics as much, but it is one of my favorite models because I think it's a great way to represent Simpson's paradox, where Simpson's paradox is the thought where you may think you have one trend going in a certain direction, but when you
Mm.
stratify into different groups, it's actually the trends going all in the opposite direction. And so
Mm.
multi-level models specifically are really strong in handling that. Um, and so, when that clicked for me in grad school, when I was first learning about this, I was just like, this is the coolest thing ever.
Yeah,
It
really
felt like
great example
magic.
there of how it's so powerful. And so to kind of give a concrete example, a common thing that Andrew Gelman and Jennifer Hill do in their book, which for sure we'll have a link to in the show notes, is so they do a lot of political research.
Mm-hmm.
And so you can, with a hierarchical model, you can break up your data into groups like regions. So it could be school districts or it could be voting districts, and then you can have every single school district or every single voting district have their own little regression model, their own weights
Mm-hmm.
within this broader model, and the broader model can pool together the individual ones. And so, yeah, it allows you to have this much more nuanced representation of what's going on that, as you point out, Mark, can allow you, for example, to avoid making the Simpsons paradox mistake. And it also it provides a lot more nuance and specificity to the model. So it means then that you can make predictions by school district or by voting district in that model. You don't have to just have your aggregate country level model,
Mm-hmm.
and so it has that extra power.
Definitely. And I would give advice to any data scientist who wants to more move into like the analytics side of things. I would highly, highly encourage learning about observational studies and that the techniques used for that space. And the reason being is that, and this is more so going to like my healthcare kind of research background, but
Mm-hmm.
either have clinical trials or randomized control
Mm-hmm.
trials where you control the
Mm-hmm.
experiment, you control the data, and therefore you can control for a lot of the bias. And there's various steps for that. But many times as data scientists, we don't control the data collection. Maybe you're doing A/B testing. There's a little bit of control there, but many times you're getting data from a product that's intended for something else, or you're getting a third party data that's coming in to combine it together. And
Mm-hmm.
so the secondary analyses that you're doing, observational studies are the way for me to like conceptualize and think through how to approach this, and more importantly, reduce bias as much as possible. to do causal inference.
Cool. Yeah, that's just a really good tip. And I do also recommend understanding those kinds of concepts well. When you can be making causal inferences or not. Great point. All right, cool. So we've got a good sense of what Humu does,
Yeah.
what you do
Oh,
there.
going
Yeah,
back, just to
yeah,
take a
yeah,
step
yeah.
back too. In addition, that was the R side. I also use a lot of Python. I probably use Python more than R for my work because I'm more on the engineering side. And
Oh, yeah.
so if I want to take the research or analytics and operationalize it and put it within a product, we're a Python based company. And so many times I won't be working with BigQuery to access the data. I'm actually accessing our data directly within the database.
Mhm.
And from there, building the various tools, and I get to do the software engineering best practices. Not of doing the unit tests, having classes, making things modular, getting the code review thoroughly from the engineering team, and that's where I have the most fun at. I really enjoy that.